last class, we discussed how we can make any shape of coil using the solid structure, right? So in the last class, we discussed how we can make our circular coil in two ways. First is wound structure, and second is solid structure. So the problem with wound structure is you have to uh, you have to make extended wires to give excitation, so that wires should touch your region. So while doing that, many times we face issue. So, then what is the convenient way is, instead of that wound structure of coil, you can just convert that to the solid structure. With both of the structure, if you'll keep your internal and external diameter same, you will get the same results. Okay, so you don't need to worry about that. So in the solid structure, giving excitation is very convenient, and also it takes less time to simulate, right? So if you want to simulate 2, 3 coils at once, then it's better to go with solid structure than to go with that wound structure. Okay, fine. So today what we will discuss is, this is the additional objectives, because the objectives that I have given in the workshop, you have seen that there were certain objectives that I told that we will cover. So all that objectives we have covered till yesterday. So because now we have time, I'm telling you some advanced things in Ansys. Okay, so in the morning session, I'll discuss how to give external excitation to the coil. So what does external excitation means, how to give it, and all I'll tell you. So we will discuss this with respect to wireless power transfer. Okay, but you can do same in transformer, inductor and all. Okay, fine. So let me share my screen. So the first day when we were discussing wireless power transfer, I told you that one block diagram, right? You guys remember that? So we have grid here, then PFC, power factor correction, then we have inverter here, then we have coil, right? This is your transmitter coil, this is your receiver coil, here rectifier, and then your load, right? Right? This is the block diagram that we have seen for wireless power transfer. So let's just see from this side. Okay, so till PFC we will not see. Okay, so if I'm calling it as inverter and rectifier, this is unidirectional circuit. So in rectifier, what we use? Diode, right? uh are you have you completed your power electronics subject? Are you aware of the converters and all? Can any one of you answer me? Are you done with your power electronics subject? Do you guys know basic converters? At least that much you know or not? Can please any one of you answer me so that I'll get to know how deep I can go, or just I have to tell you that this is the converter and all. Vamshi? Hello? Are you guys sleeping? Vamshi? At least please do answer me. Am I audible? Guys, I cannot teach you this way. Please respond. If you guys are sleeping taking this class, then please leave the class. It's fine. You can see the video. I'll ask Rakesh sir to give you attendance. But please don't attend class like this. It will be of no use. You can see the video afterwards. Every one of you who is listening to me, can you please answer if you have completed power electronics? None of you are listening or what? Okay, fine. I don't know whether you guys are listening or not. Okay, Shivani, at least you did something. And for E2 student, it's not completed yet. For E. What is this E2 and E3? Oh, Shivani? Engineering second year. So second year students are also here. Sir told me it will be like third year students. For second year, it's too soon to learn this software actually. I thought mostly your third and fourth year students. So second year students are also here. Okay, fine. You guys are not responding. I don't think. Yeah. Okay, fine. So I'll not discuss in detail then. I'll just tell you how it is. Okay, fine. So after PFC, you get some DC supply. Okay. Then you have your inverter circuit. So what does inverter do? This this converts your DC to AC, high frequency AC, because you want to transfer your power, right? And then this is your transmitter coil. This is your receiver coil. This is your receiver coil. Then what rectifier do is from AC to DC it will convert. And then you have load. Now try to understand this thing. I know you have not completed your power electronics and all, but still just try to understand it. When you will complete your power electronics subject, maybe that time you will understand it better. Okay. So the output of your inverter is AC. So if I want to reduce my block diagram, so I can just draw it from here. Okay. So you will have your AC source here. So this is the output of your inverter. Then you will have your coil, right? And similarly on secondary side, and here it will be load, right? What will be that load? So if this is R, and if you have rectifier, so on the input side, the reflected load will be 8 upon pi square into RL. Understood? So if the output of the rectifier is connected to RL load, then if you reflect it on the input side, so here if you reflect it here, it will be 8 upon pi square into RL. Okay. Now, can you see, for wireless power transfer, you need certain inductance in coil, right? So you need a certain inductance in circuit, sorry, not in coil. So for wireless power transfer, you will need a coil. So that will have certain inductance. But if there is inductance in the circuit, the VA rating of your circuit will increase, right? So reactive power will come into picture because it will have certain reactance, right? So now if I don't want this reactance, what I can do? What I can do? So do you guys heard about resonance? Have you guys heard about resonance? Okay. So if I don't want any, if I want to reduce the VA rating of my transformer, sorry, VA rating of my circuit, and I don't want this reactance, what I will do is I will place a capacitor here such that XC will becomes equal to XL, so that my circuit will operate at resonance, and at resonant condition, your circuit is purely resistive. Understood? So this is the condition for resonance. Xc is equals to XL, right? Hmm. You understand till this? So now for your circuit to operate at resonance, the condition on your frequency is this is your inductor value, and this is your capacitor value. So understood why you want your wireless power circuit to operate at resonance? Because we want to reduce the VA rating of our system, right? See, for wireless power transfer, you need coil, which will have inductance. So certain reactance will be there in the circuit. If you don't want that reactance, what you can do is you can make your circuit operate at resonance, right? So the condition for resonance is, and for that you have to add extra capacitors in the circuit, right? Extra capacitors in the circuit. This, fine. So how to add this capacitor? For the circuit, for making the circuit to operate at resonance, so the condition is Xc is equals to XL, right? So through these we will get that through this only this has arrived. So the condition on the switching frequency, uh, this is known as actually resonant frequency, is omega is equals to under root of 1 upon under root of LC. So this much you understood? How, Amshit? Do you have any doubt? Hello? You raise your hand. Do you have any doubt? Hello? You are not audible. Hmm, fine. So let's just proceed with our how we can give external excitation to our circuit. So while doing that, you will understand why I have discussed all this. Okay. This is the circuit. Sorry. This is the coil that we will be uh, dealing with for Maxwell circuit. So what is this? This is rectangular coil. How we can make this coil? Just front, I'll show you first. So this is same as the previous coil, the circular coil. So we have coil, then we have ferrite, and then we have aluminium here. So all this can be simulated with the help of this drop box, right? So can you see, your rectangular coil has certain external dimension, right? And certain inner dimension, right? That you can decide depending on your number of turns, what is the width of your wire that you are using for making the coil and all. So internal diameter, I'll just show you. When you will see this, I have parameterized every dimension, right? So X in P is internal dimension of rectangular coil for primary rectangular coil in X direction. Similarly, Y in P means internal dimension of your rectangular coil, primary rectangular coil in Y direction. So what we have is, in your internal dimensions are 330 in X direction, in Y direction it is 490. So the thickness is 3 mm. Okay. Similarly, sorry. Similarly, what is the outer dimension? In X direction, it is 420, and in Y direction, it is 580. So, yes, how we have drawn our coil yesterday, the same way we will be drawing here, but yesterday we discussed circular coil. This is rectangular coil. Understood? So, do you want me to draw this again, or you know how to draw it? Hello? If I'll give you certain dimensions, will you be able to draw this coil or not? Tell me now. Hmm. Guys, are you listening or are you sleeping? I'm not understanding. Please at least say yes or no. I'm not understanding actually. You guys are getting this or not? Please say yes or no, else I will not proceed. I'll just leave this class here only, and whenever you guys are prepared to answer me, that time I'll proceed with this class. Simply tell me, will you be able to draw a rectangular coil if I give you internal and inner and outer dimension? Just a yes or no. So, are you guys sleepy? No. So you will not be able to draw this. So should I tell you how I have drawn this? No means that only. Fine. So we will start with how we can draw the rectangular circuit and how we can give the external dimension. Okay, rectangular coil, sorry. File, new Maxwell 3D. Right? Hmm. So till now we have discussed circular coil, and we have discussed that we need certain like in circular coil we have radius, inner radius and outer radius, right? So now we will see if we want to draw a rectangular coil, how we can draw it. Okay, so steps are same. Okay, so first we will go to draw box because our coil is in rectangular shape, right? Just go to draw box, draw a box here, right click, then in upward direction. Okay, you got a box, right? Now you have to give it, you have to give the outer dimension of the rectangular coil, right? So just consider this as your coil now in rectangular shape. So outside in x direction it is 580 I'm giving. This is 420 and the this is your dimension in x direction, sorry, in y direction. This is the dimension in x direction and this is the height, right? So that I'll give 3 mm. Fine. So I want this coil to be placed at center. So the positions will be minus 210, then minus. Can you tell me what will come here? Any one of you? Can any one of you tell me what will come here? 290. Okay. Fit all. So can you see your you are getting a rectangular shape structure. So this is your rectangular coil, right? So now the outer dimension is done. Now how to draw the inner dimension? Similar rectangular we will draw, but it will be smaller in size than this rectangle, right? And then we will subtract that part. What we have done in circular coil, the same we are doing here. Okay, understood? Understood or not? Okay. If you guys don't want to say things, just tell me one thing. See, there is no point in discussing advanced things if you have not understood the basic things, right? So I don't want to rush things. Just tell me how many of you have, and still today, have not understood how to draw a geometry in Ansys. Just raise your hands. I'll not call out any names. I just want the count. Please raise your hands if you guys have not understood at all how we have drawn. Okay, let's be specific. If you guys have not understood how we have drawn the coil yesterday, please raise your hands because there will be no point in discussing advanced things if you have not understood the basic things. So we will first clear our basics. It's fine if we don't know advanced things, but At least basics we should know. I'll try to explain it to you like in detail. So because we have drawn this much geometry, we have drawn 2D transformer and inductor. So I thought you will understand this. So that's why I've rushed certain things. But I think you guys are still confused. So can you please raise your hands and tell me how many of you have not understood how we have drawn our wireless power transfer geometry? There is an option of raise hand. Please click on that if you have not understood. Or I'll just keep on telling you advanced things and you will not even understand the basics. I'll repeat myself today if the count is more. Please guys. Okay, so raise your hand if you have understood. At least do that now because you are not raising for not understood. So raise your hands if you have understood. Good one. So only one of you have understood this. Good. Raise your hands if you have understood how we have drawn the geometry yesterday. Just 4 hands I am seeing. 5. Good. At least now you are responding. 7, 8. Good. Fine. So at least I know that some of you are understanding what we are doing, right? Now, if I'll if I am telling you few things, any one of you, please say yes or no. I don't want anything more than that. I'll not ask you anything. Just say yes or no so that like I'll be interested. I'll be engaged here. Okay? Or I'll get to know if you are understanding or not. I know like at this stage at third year or you guys are even second year students, at this stage understanding this software is a big deal, right? Because some of the things you don't even know for now. You don't even know power electronics and all, right? So understanding the software, how we are doing it will be difficult for you at this stage, but still most of you, I'll not say most, many of you are understanding what we are doing. That's a big thing, right? So yesterday we discussed how we can simulate a solid solid circular coil. So today I told you that we have different types of coil, right? This this circular, then rectangular, then DD coil, DDQ coil. So don't concentrate on that. It is just to let you know that it's not necessary that the shape of your wireless power transfer coil will always be circular. Okay? It can be of different shape. Okay? And to draw that shape, see circular, to draw circular shape option is available in your Ansys, right? That we have used. But to even to draw square shape option is available. But to draw rectangular or this type of structures, you don't have any options. So what you do is you just draw a solid block that resembles this shape and then give excitation and material to that block so that it will act as a coil. Understood? Fine. So what we are drawing now is a rectangular coil. So now I have drawn a rectangular block here using this create a draw box option. So this will look like this. So here, because your coil, can you see your coil has two dimension? One is inner and one is outer. You can see everywhere. This is inner dimension, this is outer dimension, right? Because when you will wound it, it will have certain inner space, and then outer dimension is depend on how many turns you have taken, right? So that we are just imitating this shape in Ansys, right? So for outer dimension, we have drawn a box. For inner, we will draw another box, which will be just smaller in dimension from this. So, mm, what was the internal dimension? 330, 490. Okay, fine. Mm. So its X size is 330, Y size is 490, and thickness will be same as my previous box, right? So I have taken here 3 mm, right? So for position, because I want to centralize my block, right? So I'll just keep here 165, then 490 divide minus 245. And because I want it on the zero axis, so keep here 0, because I don't want it to float on air, right? I want it on the ground. So position I have kept here 0. Okay, apply. Okay. So now can you see, this is your outer dimension and this is your inner dimension. Now what I need to do is subtract this from the coil, from the outer dimension, right? So select first the outer dimension, then the box, and subtract. Can you see you got the coil? You got your coil. Can you see now? It looks like a rectangular coil, right? If you'll wound it, the shape would have looked like this only, right? Now second is that after that, what we want is ferrite and aluminum. So for that also draw another block, another box. Uh, what is the dimension of ferrite and aluminum? Plus 20, plus 20. Okay. Plus 20. Can you see here? I have actually here, uh, when I when I make my own geometry, what I do is I parameterize every dimension, and even like with, and with respect to that, I've parameterized the other dimension as well. So when I change my dimension, I don't need to change like uh, the the other object with respect to that. Example, if I just parameterize, if I'll just parameterize my dimension of rectangular coil. Example, right? So in the starting, uh, my coil is of 400 mm, right? So according to that, I have placed my ferrite and aluminum, right? But w- example, I have placed my the size of my ferrite is like 420 mm, and my aluminum is 440 mm, because you need it more than your coil, right? So if I'll change my coil from 400 to 420, then again I have to change the size of ferrite and aluminum if I don't parameterize it with respect to dimension of coil, right? So when you are parameterizing things, just parameterize all the objects that you will change when the shape of that coil will change. Understood? Understood what I'm trying to say? Hopefully you're understanding. So we are not parameterizing here. Are just draw a coil, right? Hmm. We just draw a coil. Are I'm not understanding where it went. Okay, fine, we will draw it again. Not take much time. Okay, okay, okay. Sorry. So this block I have drawn for ferrite, I forgot. Here, I'll just increase 20 mm. So X size was 4. This is 480, so it's 600. And 3 mm. And here, I'll just, because I have to place ferrite beneath my coil. So here also -3. Understood? Front. So this is at ground position. Z is equals to 0. Because I want to place my ferrite beneath my coil, so that's why I have kept here -Z position. Okay, understood? Similarly, we will draw another block. I'm just copy pasting it and increasing its dimension. 500 -3 and -3. This -3 and this -3. That's why -6. Can you see? You got your coil. So this is the copper coil, this is the ferrite coil, and this is the aluminum block. Okay, so just give material to your objects. So first is your copper. Sorry, box one is copper. Your coil is made of copper, right? Okay. Then after that, this is ferrite. Okay. Apply. Okay. And then hmm, the last one is aluminium. Right? Aluminium. Till now, you guys understood how we have drawn the geometry now for rectangle coil. How we have drawn the geometry, you understood? Can any one of you answer me, yes or no? Have you guys understood now? So, who said you will not be able to draw? Due to network issues, we are not unable to speak. Okay. There is network issue in your campus. Just say yes or no in message now. Okay. So that's why you guys, I'm not being able to hear you properly. Okay, fine. Now I understood. So Vamshi, you said that you will not be able to draw this. Now you understood how we have drawn the rectangular geometry? Okay. So should we proceed with the excitation and all? Fine. So at least you should have told me this that there is some network issue in your campus. So this is your transmitter coil. Now to make receiver coil, right? I have not given. Okay. Box 3 is ferrite. Sorry, by mistake, I've changed the materials. And box 4 is your aluminum. Some glue. Okay, okay. Now it's done. So to make transmitter coil or receiver coil, just copy paste this. Oh, don't copy paste, just select everything, then edit, duplicate. Box I have not selected now. Edit, duplicate, mirror. Okay. When you will press tab, you can see at the bottom of the screen there is dx, dy, and dz at bottom right corner. So there you can, when you will place tab, you can go there and just set the position. So I'm parameterizing the distance between transmitter and receiver. That's why I'm just parameterizing this Z element. Okay, air gap. Nth. Apply. Okay. For every other objects, just change this. Okay. Okay. Fine. So now you have transmitter and receiver coil. So we have kept our air gap as 150 mm, which is the distance between your receiver and transmitter coil. Now let's change this solution type to eddy current because we want to make our coil terminals. For making that, yesterday I told you one trick. So select your coil, right click, edit, surface, then section. We want section in this direction. So it is Y and Z, right? Can you see? Your coil is section now. But these are one body. So you just want one section in your coil for uh, excitation. For assigning the excitation, you just want one section of your coil in your coil. So what you can do is another section you can just delete. So select both the section. For that, first you have to separate them, right? So go to select the sections, then edit, boolean, then separate bodies. Now there are two separate bodies. So one you can delete. First it was one body, now there are two separate bodies. So one you can delete now. Similarly for above coil, you will do the same. Define, select the coil, citation, edit, surface, section, YZ. Okay. Now edit, boolean, separate bodies, and one you will delete. So now you just have one section in your transmitter and receiver coil. Okay, fine. Now you have to assign your coil terminals. So whatever we did yesterday, we just have to repeat that now. Assign coil terminal. So see, number of the here you will see number of conductors that you have to put. So the number of conductor is the number of turns you want in your coil. For now, I want 15 turns in my primary coil. It was 15 only, na? Uh-huh. And similarly for receiver also, I want 15 turns. Just wait. Whichever section you are taking, take both on the same side, like for receiver and a transmitter, right? Or else you will get confused how to assign the direction. Edit section. By like mistake, I have deleted the other section. So I'm just making it again. Hmm. So now they both have section in the Same direction, right? Right. One coil terminal we are done with one coil terminal. Then second, select the terminal, select excitation, coil terminal, number of conductors 15, same direction. Okay. If you are choosing this direction for the below coil, the same direction should be followed in receiver. So whatever direction you choose, it should be same. Sign excitation, coil terminal 15, just say primary. Then for about assign excitation, coil terminal 15, secondary, same direction. Okay, so we have coil term. Sorry, that's why. So I thought this circuit is selected. Actually, the above one was selected. That's why I was not getting coil terminal here. We will do it again. It's fine. Primary. Okay. Let's just close this circuit so that we will not get confused. Assign excitation, coil terminal 15. This is secondary. Now, what is the next step? Next step is to add winding here, right? So excitation, add winding. One is for primary, current, stranded, because we have given number of turns. So stranded type is current. You can, here multiple options are given. You can put voltage also, but for now we are just dealing with current. So current. Okay, current. Then I. G10 initial. Initial 10 ampere I'm selecting. Similarly, we have to make second winding, add winding, secondary. So for secondary windings, you have two options. Either you can give I as current, which is the same current as primary, and give a phase of 90 degree, or you can just put 0 here. Both will work same. Okay? Because in wireless power transfer, you only give excitation to your primary, right? So in secondary, either you can put I and a phase of 90 degree, or you can just put 0 there. Both will work same. Okay. Then assign coil, add coil terminal, add terminal. This is secondary. Okay. Then here add terminal, primary. Fine. Primary and secondary is done. Now parameters, assign matrix. This we do to get self-inductance and mutual inductance of the coil. Okay, if you'll not do this, you'll not be able to analyze it. Then mesh operation. For ferrite, you need one mesh operation, assign mesh operation inside selection length base. Okay, default we will keep, it's fine. Then copper, assign mesh operation inside select length base. Then aluminum. Assign excitation. No, sorry. Assign mesh operation inside selection length base is 120. Okay, fine. Then analysis setup, add solution setup. Number of passes, percentage error, we will somewhat increase. Then solver is the important thing here. Here you have to keep your frequency. So I told you then for wireless, because my application is electric vehicle, I always analyze it for 85 kilohertz. But if your application is different and you can go to higher frequency, you can put any frequency here. Okay. Then optimetrics, add parametric, add. So if I want to analyze it for air gap to 200, somewhere your 20, fine. So it is analyzed it for 100, 140, 180, and 200. Okay. So yesterday, when we were animating our field, that day we have seen that you are getting it for one air gap only. So for getting it all sweep, you have to select this option, save field and mesh. In option, save field and mesh will do what it will do for every sweep. For every sweep, it will save the field. Okay. Now we will see how it will happen. So save field and mesh, please select this option. Then okay. I think we are done. Let's just validate it. Project 3, save as desktop coil, some rectangular coil. Save. Okay. And just analyze it. First, we are analyzing it normally. Okay. Take time. Well, I think it will take a lot of time to simulate. Let's just wait. Let's just wait for 5 minutes. It will get simulated. I'm simulating it because I want to understand few things why we are going for external excitation. Actually, I was not planning to draw this geometry, but because you guys told that you will not be able to draw this, that's why I told you how to draw rectangular coil also. So till the time it is getting simulated. Now, if I tell you to draw any shape of the coil, will you be able to do that? If I tell you how the current is flowing, and if I just tell you the dimension of the coil, will you be able to draw it now? Hello? 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 If I tell you, oh, sorry, please, I forgot that you guys cannot speak. So please reply, please put in chat. Will you be able to draw it? If I'll give you any geometry now, will you be able to draw it any shape of coil? Please type in message yes or no. Okay, fine. It is anyways your assignment. So I'll give you some different shape and you have to draw it. So it is one of your assignment. Uh, if you have not understood till now, please let me know. I can repeat myself because today is the last class and after that you have to rely on videos and all only. Today you can ask me any doubt, like anything that you have not understood. I'll repeat myself. After today, you just have to rely on videos then. So it is just getting simulated. Hmm. And so your simulation is done. Now analysis in result, right click on result, create eddy current, rectangular plot or data table. So if you want values, then data table. If you want plots, then rectangular plot. Air gap. So we will see how your coupling coefficient is varying. So coupling coefficient you see just in between primary and secondary coil, right? What happened? There was an error in simulation of current I have given, right? It's 10 ampere. Given all the values, right? Something that it air gap. I have mesh of friction is correct. Happened. Sim have you guys noticed if I've done something wrong while simulating? 15 turns, right? This is also 15 turns. Everything I did correctly only. Why it is showing error? Current standard I right 90-degree. Let's see the field. Field is also not showing. While simulating, I might have done something wrong. Okay, let me check. Okay. Have you guys noticed it? What I have done wrong? Because I have to cross check it again then. This is copper. This is copper, right? This is done. Then ferrite, 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 ferrite. Then aluminium, aluminium, right? Primary, secondary, 15 turns, 15 turns. This is also correct. This, Yeah, on this section is also correct. Mhm. And in parameters matrix, I've selected. This is also correct. Mesh operation I have given. That is also correct. Analysis setup 85 kilowatts. Right. This is also correct. The matrix at 50 safe field and mesh. Oh, error is also showing. No error is showing. What is the issue? We have not got the result. Yeah, let's analyze it again. Just wait. I'll not parameterize it. I'll just first check on one value. Okay. Air cap coupling coefficient. I just cross checked, but I don't think I've done anything wrong. I'm not understanding why results like that I'm getting. So this is the same coil, right? Here, if you'll see the result, it is not parameterized. Still one value we can see. Okay, we have to run it again. $75. It's too much values. This much I don't want. 50. Update. Okay. Save soon. Okay. Can you guys guess why we are not getting the results? One basic mistake I did, and I have not understood it. Can you guys guess? Okay. So the mistake we did is we have not given region only. We have just given aluminum, copper, and ferrite. But I told you for simulating your geometry, the region is most important thing. And I just forgot. Sorry. Okay, fine. So now you understand if you will not give region, you will not get proper result. So by my mistake, please learn. Don't forget to give region. Okay. I just debugged it twice, thrice. Still, I have not understood that I have not given region. I'm so sorry for that. So now you got the importance of giving region. Okay. Yes. Minus x. Fine. So now when you will run it, you will get proper results. Oh, is there any problem with the geometry? Okay, fine. Now just validate it and run it. Now you will get proper results. So at least by my mistake, you have understood the importance of region. So even if you have done everything correctly, if you will not enclose your geometry under a environment, it will not give you proper results. It will not give you results at all. Okay, understood? Fine. can you see at now? Actually, I have not sweep it to air gap. So the air gap that is there is for 50 mm. So for 50 mm, you are getting your coupling coefficient as 0.33, which is a good enough coupling coefficient. You can mm, also see the flux linkage. Field D should be only the values are not proper. That's why you are not being able to see the proper flux linkage here. Okay. But you can see from here because you are getting coupling coefficient. It means that proper linkage is happening. Okay. Fine. So here, if you will see the number of options, so you have loss option that I told you you can calculate. In winding option, you have induced voltage, flux linkage, and all. But when you will click on induced voltage, in data table we will see because we have single value. Mm. Magnitude. So when you will see your magnitude, you are getting it for some current and all, but like this is IXL, right? This is the induced voltage in your primary winding, but the value of current that you give here is like, sorry, the value of current that you give here is some random value, right? You have calculated it or you have given some random value. But now if I want to see if my circuit have some excitation, if my circuit have like if I'm giving like 400-volt as my excitation, so how will my circuit behave? For that, there is one option known as external winding option. So it will not take a it will not take direct values of current, but it will take current from that circuit. Okay, what we call it as external circuit. So that circuit looks something like this. So now this values we know because we are giving the excitation, right? So we will form one circuit such that the value of current that that we have given as one a specific value that we will take from this circuit. Understood? So this is the same coil, and this is the circuit that we have to make. But think we can, I think for morning session, we will stop here. In the next session, we will see how to give external excitation to the circuit. In the meantime, I'll just run it for different values of air gap. Okay, so that I can show you the result more appropriately. Understood? Okay, and the importance of that external circuit and all, we will be able to see that. Okay, fine. So if you guys don't have any doubt, for the morning session, we will stop here. The evening session will be from 6 to 8, and that will be our last session. So if you guys have any doubt in anything that we have discussed till now, you can just we can just discuss in that class. Okay, fine. So I'll give you one assignment also, maybe today or by tomorrow. Then I don't know whether you have to submit the like the submission details and all, that Rakesh sir will tell you how to submit it and all. Fine, fine. So we will just stop here.